Hello everyone. Today let's solve the problem number 2 to 5 quickly. So what the question states here, before moving on to the question name is implement stack using queues, right? So what the question states here, we have to implement a stack using only two queues, right? We have to implement the stack using only two queues with standard queue operations. So we have to make use of the standard queue operations. We cannot go with the array DQ. So we can go with the array DQ as well, right? We can just make use of the operations that is provided by the array DQ as well to perform the stack or the queue operations, right? So before making use of that one, so first itself they have given here implement a stack using only two queues with the standard queue operations. NQ, DQ, peak, size is empty are the operations that is supported. NQ, DQ, peak, size is empty. These are the operations that are supported. And what are the methods that are supported? Push, pop, top, and empty. Push, pop, top, and empty. Here you can clearly see we have push, top, pop, and empty. Push, top, pop, and empty are the methods that are supported, right? It should follow LIFO, last in, first out behavior using only FIFO queues. First in, first out, this one queues, right? LIFO is nothing but the last in, first out, basically the stack behavior, right? It should follow LIFO, last in, first out behavior using first in, first out queues or FIFO queues, right? So we can only push to back and pop or peek from front. We can only push to back and pop or peek from front. So that's what they have given in the question. So that's what they have given in the question. I hope the question part is completely clear. I hope the question part is completely clear, right? So here we have been given four operations. And one more thing, before writing the code, let me tell you one thing. Accordingly with the question here, my stack, the return value, this is the initialization part. There is no return value. Return value will always be null, and we are not performing anything this push, right? We will be pushing numbers to the stack. So return value will always be null. We are not performing any operations that return something here in case of push. So push will always be null as well. So only the pop, top, and empty consists of the return value, and the return value of the pop and top will be number, right? So here you can clearly see we are going with the numbers. We are dealing with the integers right here. So here pop and top consists of the return value number, and finally empty. Empty means is empty will be usually using of, right? So whether we have to check whether that is empty or not. So usually we'll be going with the this one boolean value, true or false. The return value of the empty function will be usually boolean value, true or false. I hope this part is completely clear, right? I hope this part is completely clear. Let me do one thing. Let me clear this one so that this looks good, right? So this is fine. So let's go with the initialization part first. Let's go with the initialization part first. So before writing the code, let's discuss the approach followed by the complexities, and then let's write the code, right? So let's discuss the approach first. Let's before writing the code basically, right? So let's come to the first example here. We have my stack push, push, top, pop, and empty. And push is nothing but the this one push, top, pop, and empty are nothing but the supported methods, and my stack is nothing but this one initialization part. This one is the initialization, and these four push, top, pop, and empty are the methods that are supported basically, right? Push and my stack nothing but initialization, and push consists of the return value always null, and top pop consists of the return value number, and empty consists of the return value boolean value. Basically empty consists of the boolean value, either it can be true or false, right? So first accordingly with the data they have given, this is the data I'm speaking of, the second line. Accordingly with the data they have given, here we have the empty bracket, here we have the empty bracket here. So what we are doing, my stack of initialization, this is fine, initialization part. So this will be null, initially this will be null, this is fine, right? So what about push? We are going with push of 1 here. Push of 1 means we are pushing, we'll be making use of the queues here. One more thing, we will be making use of the standard queue. By making use of the standard queue operations only, we have to solve this problem. They have strictly mentioned this one in the question. And also the operations that are supported within the queue is NQ, DQ, peak, size, and is empty. These five operations are supported. NQ, DQ, peak, size, is empty. Again, I'm telling NQ, DQ, peak, size, and empty, right? So here again they have mentioned we have to make use of the standard queue this one operations, not we cannot make use of array decay or something, right? I hope this part is completely clear. So this will be going with the queue. Just remember this one will be going with the will be making use of the data structure queue as they have mentioned in the question itself, right? So here in this case we will push one to queue. So we'll be maintaining two queues, one is q1 and another one is q2, right? So we will push first this one push of one, we will push 1 to q1, we will push 1 to q1. Now within the q1 we have 1 and we will push 2, right? So then we have to push 2, this operation we are dealing with the third one right now. We have to push 2, right? So we will move all of q1 to q2, right? We will move all of q1 to q2. Now q1 had 1 initially and we are moving the value 1 along with the value 2 to the q2. Now q2 consists of 2 and 1. So this is first in first out, right? We are going with the queue, not the stack. So in the stack we would have represented 1 and 2 instead of 2 1. So now q2 consists of 2 and 1. Now q2 consists of 2 and 1. So top what we'll be doing here, next we have the top operation. Top it is having the return value number, right? So top here, top of empty, this one we have given, right? Front of q1 is nothing but 2 here. Front of q1, this one front of q1 is nothing but 2. Q1 is also 2 because we have 2 pushed 2 to the q1. First we pushed 1 to the q1 and then we pushed 2 to the q1 and then all the elements in q1 we moved to q2 basically, right? So front of the q1 consists of the 2, front of the q1 consists of the 2. So we have to return 2 in this case. We have to return 2 in this case because this is the top operation. Top is nothing but the front. So front of the queue is nothing but the 2, right? So next we have the pop operation, right? Next we have the pop of this one empty, this one they have given empty array, right? So this one we are removing front from q1, we are removing front from q1. In this case we have to remove what we have in the front, 2. We have returned 2 in the previous step, so we have to return this one. What do we call? We are removing 2. We are removing front from q1, nothing but we have to return 2. What we are removing, the value 2, right? In this case also we have to return 2, in this case also we have to return 2, right? So for this we'll be making use of the queue operations. We have kept q1 and q2, we are going with the q1 and q2, right? So the last step here is empty, the last step here is empty. So q1 is quite obviously not empty. We have just removed the value 2 and q1 still consists of the value 1 and q2 consists of 2 and 1. This is different. We are not considering q2 yet. So we are only considering q1. Q1 still considers the value, still consists of the value 1. In this case, we are checking whether it is empty or not. No, right? It is not empty. It consists of the value 1 here. So in this case we have to return false, not the true. So this is how we got the output null 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 2 to false, right? Simple, very simple, right? So let's articulate the same thing whatever we discussed in the form of code. Before that, let's discuss the complexities as well, right? So let's discuss the complexities and then let's write the code. So what will be the time complexity here? The time complexity would be this one. For the time complexity for the push operation, push of x means any number, any value, it will be big of n because we are moving elements, right? We are moving elements from q1 to q2 and the time complexity of the pop, top and empty would be big O of 1 and the space complexity would be big O of n because we are storing n elements in 2 queues. Any number of elements can be there, right? So we are storing n elements in 2 queues, so the space complexity would be big of n. Space complexity would be big of n for the push up, the complexity, the time complexity and the space complexity would be big of n for the push operation and the this one for the push operation, and the overall space complexity would be big of n as well. And for the pop, top and empty operations, the time complexity would be big of 1. I hope the complexities part is completely clear, right? So now as we are completely familiar with this one, what do we call, um, approach as well as the complexities, we are good to write the code. Let's start writing the code. Initially, let's go with the initialization part here. What shall we initialize? Before initialization, I have to tell you one thing. We have to uh, create the queue, right? So we have to make use of the queue. Basically, we are going with the two queues here. So before the initialization part, let's go with queue here. Queue of integer. This one will be q1 first queue, and one more queue we will be making use of. So here this will be I, capital I, again integer, again one more queue of integer here, q2. This is fine. So let's come to the initialization part here. So this one, public my stack, so they have already mentioned this one, right? So we have to initialize the queue here. So here this one will be q1 equals new standard queue, right? So we'll be going with the linked list here instead of the array dq. So usually I make use of the array dq rather than this one. Standard queues or the standard tags, standard stacks basically, right? So here this is fine, and also let's go with the q2. Here this will be new linked list. So this is fine. Hope this part is completely clear. We are done with the initialization part. We are just initializing the queues, q1 and q2 here. So let's come to the push operation here, push method. So inside this push function, what we'll do, we have to add the new element to the q2. So first we have to push that one to the q1, and we have to add the new element from q1 to q2, right? So here let's make use of the offer. Let's make use of the offer here, offer operation that the push provides, that the queue provides, sorry, standard queue provides. Here in this case I'll just go with q2 dot offer of x. This is fine. Q2 dot offer of x. We are just adding the new element to q2 by making use of the operation offer, right? So let's come to the while loop. Let's move on with the next line here. If q1 is not empty, means if not of q1 dot is empty, then what we'll do here within the while loop, the next step is we have to move all the elements from q1 to q2 to maintain the particular order. That's what we did uh, while we considered the example one. I have showed that one clearly. We moved the elements from q1 to q2, right? 2 1. First we pushed 1, then we pushed 2. Front consisted of the 2 and the rear consisted of 1, and then we pushed all, then we moved all the elements from q1 to q2, right? So we have to move all the elements from q1 to q2 to maintain the order. So here again we'll be making use of the offer operation that the queue provides. So this will be q2 dot offer of q1 dot poll. This is fine. Q1 dot poll. So this is function. We are making use of the poll operation. This is fine. Next, so let me leave space so that this looks good. So next step here is we have to sum q1 and q2. We have to sum the q1 and q2. So again, I'll just go with q here, integer. We are just articulating the same thing that we discussed in the approach in the form of code here, right? So here q integer, this one I'll just make use of the temp variable. Temp, let's initialize this one to q1. This is fine. So the next step here would be q1, let's assign this one to q2. This is fine. The final step here is q2, let's assign this one to the temp. This is fine. I hope this part is completely clear. Let's do one thing. We are done with the my stack, nothing but the, sorry, we are done with the push operation. This one we are done with the push method basically, right? So next let's move on with the pop method. Let's move on with the pop method. Right here we just have to return this one. We have to just remove from the front of the queue. If you remember in the pop we had 2 and 1 in the q1, right? So we just removed the element in the front, nothing but 2. So that is the reason we return 2 here in this case, right? So I said this one several times. So here we just return here q1 dot poll. Poll is the operation that we'll be making use of, right? So q1 dot poll to remove the element from the basically front, right? So we are just removing from front of q1 here, nothing but the top, from the top of the stack basically, right? So we are simulating the stack operations by making use of the two queues here, right? So here this is fine. Let's go with the top. So we are left with top and empty methods, right? Within the top method, let's do one thing. Here we just have to peek front of q1, nothing but top of the stack here. Again, instead of poll, we'll be making use of the peek here. Return peek q1 dot peek. This is fine. Let's move on with the final method, nothing but the empty. Here, in this case, we'll be making use of the is empty operation that the queue provides. If the stack is empty, means if q1 is empty, we need to return boolean value true. If it is not empty, is empty operation basically returns the boolean value, right? Is empty operation basically returns the boolean value. If the queue is empty, or if the stack is empty, basically, right, we are going with the q1, right? We are simulating the stack by making use of the queues. Here, if the stack is empty, or if q1 is empty, in this case we are simulating by making use of q1, right? So here in this case, if q1 is empty, then we have to return boolean value true, right? If it is not empty, then we have to return false. In this case, we were left with the value 1. We removed 2 and we returned 2 during the pop operation, but still we were left with a 1, right? So we pushed 1 before 2. If you remember, we were left with the value 1. So it is not empty, stack is not empty, or q1 is not empty in this case. So in this case, we got the output false. So how can we articulate the same thing in the form of code? We just have to give here return is empty. We'll be making use of the operation is empty here. So this one has to be q1. So we are going with the q1, right? So again, operation. So this is fine. So let me format the code once and let me hit the run button. So I hope this works, man. Let's see. Yeah, you can clearly see here the sample test case is getting passed. So let me hit the submit button. I hope this works for all the test cases. Let's see. I hope this works, man, for all the test cases. Let's see. Yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case, right? So I hope the solution part is completely clear along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.